Hi, now in part 2 we will build on top of what we have learned so far and continue doing this analysis. And it is essentially going to be regression analysis. I want to emphasize the importance of regression here because all those buzzwords you hear like AI, machine learning, they all depend on these kind of fundamental concepts. I highly recommend getting comfortable with linear and logistic regression first. I mean, you should get super comfortable with them, and it will help you. They will help you in the future. You will have a better time when you are studying more advanced topics, and you can also create difference in a job interview or any place you go and talk about these kind of concepts. Having a deep understanding about regression analysis makes difference, really. And we follow this textbook to have a structured way of going, and you should know also they have an active GitHub repo. You can read through and find really useful information here, and later sometime you can even try contributing. This can be your chance for contributing to an open source analysis project. Anyway, let me open my Sketchpad and try to visualize what we did last time, because I want to build on top of what we did so far. We have this coordinate system, the x and y. Our y variable or target variable is price, and the x variable or the independent variable is the distance. This y is the dependent variable. It is depending on distance. It is depending on x. That's why. Sometimes we call it target variable, because in prediction practices it is our target to predict, right? And we had hotel prices. Each dot was a hotel in the visualization, and we had dots like this, right? And let's say this is kilometer number 1, kilometer number 2, kilometer number 3. Let's say 3 is here, and then we have 12 maybe here. These are kilometers representing the distance to the city center in Vienna. In regression, you want to find a function that can represent this phenomena. We can write a notation such like this. So y, the left-hand side variable, it is left-hand side variable because it is on the left-hand side of this equation, is depending on x here. So that's the independent variable, or the right-hand side variable because it is on the right-hand side, right? Sometimes it is referred as predictor because that's what predicting the price. There's also an error term here. We are disregarding it for the time being. Okay, we can divide the regression analysis into two groups, maybe non-parameterized regression and parameterized regression. And I recommend first starting with non-parameterized regression when you do exploratory data analysis. And when you are doing the regression, you don't want to talk about causality most of the time. At least at this stage, we shouldn't be talking about something causing something, like distance causing price. That's a wrong way of communicating. We want to communicate something like with the decreasing and increasing distance, decreasing price and increasing price. We can claim these kind of things. We can communicate it this way. I will come to that later, but I just want to emphasize the kind of terminology and the kind of phrases you should choose. We are interested in average price, changing prices on average based on distance. That's how we will be talking about it. And remember, always remember, regression talks about averages. Anyway, we said non-parameterized. So this is where 3 kilometers is, and we may have a line here and divide our data set into two groups. The first group being close by locations, the second group being far away locations. So this is our close by group. And this is our faraway group. And then you find the averages. Maybe you have the close by hotels averages over here somewhere, this point, and it can be something like 150 euros. And then you have the average of the faraway locations, and maybe that average price is something around 90 euros. You find these averages by groups, by categories, and then report it back to your stakeholders. And essentially what you are reporting is just averages, of course, and this is what I mean by non-parameterized regression. You don't have parameters in this case. When you have parameters, the regression would look like this. I will not go into the details of parameterized regression right now, but I just want to give a highlight. You would have an equation such like this, and the parameterized regression in a visualization would look like, let me take another color here, something like maybe green. Okay. So you would find a curve or a line, let's say, like this in the parameterized one, because it's a function that can be represented visually such like this. There will be two important things when we work on this, we will see. The first one is the intercept, and the second one is the beta coefficient. And of course this x is still the distance. This beta coefficient is representing the slope of this curve, or the angle, if you will. So there's an angle here, right? We can even draw a triangle here, but anyway, I don't want to do that. I just want to highlight the angle here, the slope. So this beta is the slope, and it represents how sharp it is going down in this example, right? The price is decreasing as you increase the distance, but how sharp it is decreasing. That's what beta coefficient tells us. And this alpha is the intercept. It is where this line is crossing the y-axis. So if it is crossing here at 110, then your alpha becomes 110. And similarly, finding a beta is also important, because that will affect everything in your modeling. That will affect the way you communicate, that this beta coefficient will affect basically everything you have in your project. That's why finding a correct beta is important. And we should always be suspicious about finding our beta coefficients and ask why. Why did I get this beta coefficient? How it looks like. But anyway, as I said, I don't want to go into the details of this at the moment. I want to focus on this non-parameterized first, because that's how you should start your regression studies. Essentially, we did something similar. Over here, at the end of our first practice session, we found this visualization or table, and it was showing us the average price per neighborhood. In each neighborhood, we have an average price already, a non-parameterized regression. So if your friend was going to this neighborhood called, I don't know, Schueschott, I don't know how to read that, sorry, then you would tell them what kind of average price they can expect. And it's always the average, changing average prices. What we will do now is something similar. I will try to write a code that can represent this thing we draw here, okay? Let's start with a markdown. I want to write down what I want. I want regression analysis, okay? And the subtitle 1, non-parameterized. And this non-parameterized will be based on distance categories. They will be close and far hotels. And the condition will be using the distance field in our data. If it is smaller than or equal to 3, let's say, we will report that it is a close by hotel. Otherwise, we will report it's a far away hotel. Let's see what we can do with this. I highly recommend first writing these down, and then you will not get lost. I forgot how the data looked like, by the way. Let's check the first 2 columns. Nice. Okay, we have our distance here somewhere. Each row is a hotel, and this hotel is 2.7 kilometers away from the city center. And city center is basically where that huge cathedral is. These 2 hotels are in close by locations. Okay, but of course I don't want to look up manually like this. We need a new column. Next to this rating, we need to create a new column, and this new column will hold the encodings of close and far. How do we create a new column? First, let's do that. I'm going to use the location method. This log stands for location. If I use a column here before the comma, it means I want all the rows. This is standing for all the rows, and all the rows, and also my column. Let's call it my field. And I want to populate this column, right? How many times, how many cells would I have? I would have the number of cells equal to the length of this data frame, right? I want to write this explicitly, so that's why I will use a list comprehension here, and perhaps a little bit different method, but I want to be explicit. So I want all the cells to be none. Okay, for I in range of length of df. So of course there are better and different ways of creating a column, but I want to explicitly show you here that we are creating none. How many times do we create it? We create it number of times equal to the length of this data frame. Let's run this and see what it is producing. Hopefully it will not throw an error. Okay, we are lucky, there is no error. Let's check what it gives us. I need 2 rows only. So I have this my field, and yeah, it is populated with nonce. Basically I didn't encode anything into it. So this is how you create a new field. Anyway, I don't need a field with name my field. Actually, I will rename this. Okay, I will rename this column called my field. But this rename takes a dictionary, and this my field will become category. Okay, that's what we are encoding to the dictionary here. Change the field name my field to category. Okay, this is how rename works. Hopefully it will work. I don't know, we will see. Let's run it and see first if it is running properly. Yeah, see, it changes over here. I think this takes also in place. Let me check if it is doing that. Yeah, it takes it, of course. Now I changed my df. I stored it here. Okay. Now we have the new field called category, but I want to encode far and close strings into it based on this condition. There are different ways of doing that, but I will use Boolean masking. This is, I think, more explicit, and later we can practice the other methods as well. First, I need a condition for close by hotels. that condition will be something like df distance smaller than or equal to 3 kilometers. That's what we said, right? Also, let's use the parentheses for readability here. And I need another condition for faraways. Again, very similar, but otherwise greater than 3. Now what do I have here? I have 2 Boolean series. Let's print it down. So this is how the condition close looks like, and the far. These are just Boolean series. However, if you pass these Boolean series, by the way, in this Boolean series, each record represents if the condition is true or not. In this one, in this condition for faraway locations, we have a false for each record where we have this condition as false. So in these locations, this condition is not true. This faraway condition is not true. Okay. If you pass this Boolean series into your data frame, and this is what Boolean masking is, you will get that data frame. See, the indices start with 19 here. So you get only the faraway hotels in this one. Let's check only the head, right? If we check the distance now, see 3.4, 3.4, 4 point, these are all the faraway. So we achieved getting the faraway hotels. But of course we don't want them in separate data frames. We want them we want this field in our original data frame. Here, what I'm gonna try is I will print the indices. Here I am telling Pandas to give me those indices where hotels are far away, okay? And you want to encode far only for these indices in the data frame. And you can even call this for readability far IDX. It means far hotels indices, okay? Let's run this for IDX. Okay, these are our indices. And then similarly, we will create the same, not the same, but very similar, close by indices, right? df passing the condition of close and index. Now we have both indices. How to use these indices to modify these cells? That's the question. Let's try something now with this faraway indices. So I still want my original data frame, and I want to use the location method on each cell where I have this faraway indices. Okay, and the name of the field is category. I want to populate these categories, and I want to use again that explicit method of encoding. So I want these to be encoded as far for I in a range of, which one to use? Let's use the far indices length. So this is, I guess, around 50. I have around 50-55 faraway hotels, and this list should have around exactly the same number of lengths. Okay, and if you run this, let's see if it will throw an error. It didn't. Let's check our head. Okay, here these are still none because these distances are close by hotels. Let's copy this and underneath, repeat the same thing for close by hotels. So I want to change only those indices where I have the close by indices, okay? In our first practice, we used the colon here before comma because we wanted all the rows. In here, we don't want all the rows. We want the far away indices and close by indices. That's why. That's how this location logic works. So this time again, I want to change the category and I want it to be close. And how many times do I need it? A length equal to this one. Close IDX length. Let's run this, and this time I hope we will see we encoded close by hotels here. To verify, you can count the values after creating a field. You use this value counts function and see how many times it happens. So close by hotels 376, far away hotels 52, and the total number is matching to the length of this data frame as well, and this is what we were expecting already, right? Here in the non-parameterized regression method, the last part is creating the group by and reporting the averages, because that will be your prediction will be based on those averages. How we can do that? Again, I will use this explicit method. I want to repeat the price. I want to select two columns only, okay? The price and category. And I want to group by this category because I want these two groups, right? That's why I created this. And I want the average. This mean function will give you the average. I also recommend using the pipelining methods. So this is not really a very long pipe, but just to practice it and show you how it works. You may want to write it this way, because later this thing may be several lines and it can get really complex, and it will be easier to read later for your future self and also for your colleagues. You can use these parentheses to do that. And this is our result for non-parameterized regression. If a hotel is close by, you report 134. If it's far away, you report 107. And you always predict these two numbers. It is like randomly talking to your friend. Like if they are going to Vienna for holiday, you would tell them, well, if it is close to city center, I guess it will be the hotel price will be around 135. If you a little go far away, then you can find something with 100 euro. And this is how your studies for regression should start, because these establish your baseline. You learn the ballpark numbers, and then in your next study, if you find something strange, you immediately recognize, and you use them for benchmarking. It's quite useful. This is exact representation of this, actually, without the green line, of course. The green line is the parameterized regression. The black one is the non-parameterized one. Okay, great. You can also dive into this repo and check where they are doing parameterized and non-parameterized regression. It would be useful. If you get lost into the repo, you can check the case studies on their website over here. And of course, you can contact me. If you happen to be looking for these drawings, I keep them, I save them, and I can share later if you need them as well. All right, in the next section, We will slowly start doing the parameterized regression. We will dive into this y equals alpha plus beta x function. We will see its implementation in some libraries, not only scikit-learn, but I want to look at also the stats models libraries for that. Okay, see you in the next one.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.